Yeah, no, I understand. I'm just saying, if you were to take strontium 90 and put it in a soda, hear me out. You put it in a soda, and then it glows like Nuka-Cola Quantum, and then we sell enough of these bad boys to recoup the cost. It's almost a perfect plan. The only thing I have to do now is finish this sentence uninterrupted. Love you, bye. Oh, hello, I wasn't. Hello, and welcome to Office Hours, a live component of the facility where good old Professor Kyle here opens up his blast doors and lets all of you at the facility, my professors, my research associates, my interns who get me coffee, and you members of the general public, ask me any old science-y, pop culture-y, radioactively question with the hope of being entertained and informed. If you want to join the... That sounded way too formal. If you want to join the facility, continue on this conversation, of course, go to patreon.com/Kyle Hill and join the facility today. Drape on a silky white lab coat. But if you're just joining me now and for the first time, we're going to be going through a number of topics today. In addition to taking all of your comments and questions that I can get to, we're going to be talking about Fukushima and the radioactive treatment of water. We're going to be talking about T-Rex. That's plural. It's not T-Rexes. T-Rex and how many of them lived and died on this planet. We'll be talking about the first flight on Mars, literally, which is pretty cool. We'll also be talking about me looking like that on the latest episode of the facility. And we'll be talking about black holes if we get to it. But if you really, really, really want to have me see something and respond to it, you can also try YouTube Super Chat. As you're seeing happening right now in real time, I can't promise that I'll get to all of them, but I'll try my very best because you are simping for all of our advanced technology here at the facility, which I appreciate. Elizabeth Calvert, as always, with the 50, who says, hope you and Aria are doing well. I ruptured a pulley in my finger on Sunday, so I'm not doing super great. Question from my tiny human Alex: why are Legos made out of plastic instead of some other kind of material? Well, the good thing about plastic is that it is light and it's extremely robust and it's easy to make in mass. It's easy to make a lot of plastic at a time. If you have this gigantic mold, you make plastic, the polymers, really, really hot, and you put them into the mold, you let them dry. And what comes out are these very light, very strong, and very cheap Lego bricks. You know they're strong if you've ever stepped on one and it feels like death in your foot. And they're so strong and engineering-wise robust that I think you could build like a tower of them like a mile high before the bottom one would mechanically fail. So they're very, very strong for the material. Steve Jester said, what happened to your finger? I was rock climbing and I was pulling on something. I'm still not in climbing shape after lockdown, and you hear a sound like this. You're pulling, you hear a sound like this, and it's one of your pulleys that keeps your tendons against your finger partially rupturing. We'll see if it's fully ruptured. And we have Tony T with the 756. Let's pause the super chat so everyone watching can get to the kind of depressing Fukushima. It's actually not depressing. I want to set the record straight on Fukushima. Tony T with the 50 says, no question, just a simp for science. Continue this for as long as you can. Thank you. I can't not continue it. In fact, I can't not stop myself from talking about nuclear stuff. It's all I do. So, the Fukushima Daiichi disaster in Japan. No, Chris, you can't do that. Chris Sparks with another $500 donation coming in hot, like he did last week. Chris, that is way too much money. You could buy a PS5 with that. So this next segment is dedicated, of course, to Chris Sparks, who wants me to tell you all about Fukushima. The Fukushima Daiichi nuclear disaster happened about a decade ago, and what happened was due to a lack of foresight by the creators of the power plant. They didn't have all the necessary evacuation plans, contingency plans in place. And so when a earthquake occurred, the reactors here at Fukushima naturally took themselves offline. They said, stop making nuclear power. Now, you make nuclear power. Yeah, Chris is what the kids call a PogChamp. And so to make nuclear power, you take nuclear fuel and you bring it close together. When you bring nuclear fuel close together, all the particles flying out from that nuclear material, radioactivity, all the particles flying out, hit the other material, and if they're close enough, it can cause a chain reaction to release more particles than they otherwise would if they were far apart. We use this chain reaction to generate a lot of heat, to boil water, to turn turbines, to make electricity. So steam, basically. Steam power, but with the most physicsy of ways. So the reactors at Fukushima decided to take themselves offline when they had this power disturbance from the earthquake. And what turned on was backup generators, generators that would keep the coolant running through the reactors, even though they weren't generating chain reaction heat anymore. They still have this decay, so-called decay heat. So nuclear material is always going to get hot if you have a lot of it together, like one rod. It can get hot. What they didn't anticipate was after this earthquake, there was a large tsunami, a large wave that came and covered the facility and, not mine, and flooded the lower levels in the reactors in this power plant. Now, when the bottom parts of these reactors were flooded, these emergency generators failed, and so they were no longer cooling the nuclear fuel. When you don't cool nuclear fuel, it literally melts down. A meltdown is a literal term. The nuclear fuel gets so hot that it melts, vaporizes. It can cause steam explosions, hydrogen explosions, and that's what happened at Fukushima 3 times, I believe. And those explosions can throw nuclear material into the air. And as nuclear material is dispersing itself through the air, through everywhere, water can get contaminated, land can get contaminated. It was a disaster, no doubt about it. So for the last 10 years, Japan has been dealing with this disaster. And one of the things that they have to deal with, of course, is all the contaminated water on site. Now, this has been ruffling many feathers. The Japanese government has now approved an idea to release treated radioactive water back into the ocean as a way to get rid of it. Now, a lot of you watching, I saw a lot of you in the chat beforehand. A lot of you watching were saying, well, it looked like you had a misconception, rather. It looked like you just thought we were dumping toxic waste or nuclear waste directly into the ocean like you would just take a dump truck and pour garbage into the ocean. That is not true. What is happening here is that they are treating the water first and then releasing it after diluting it. But Kyle, isn't radioactive stuff always bad? Well, that depends on how you remove the radioactive stuff. So if we want to look at this from an engineering perspective, as I do, I actually have a degree in environmental engineering, and that includes wastewater treatment, and that's what they are doing. So I have an idea, and this is what that idea is. So this is what more or less they're going to be doing. They're going to be taking the contaminated water that has radioactive particles and fission detritus in it, and they're going to be putting it through a couple of different tanks. Now, in each of these tanks, there is a different mixture, and these mixtures contain particles, elements like iron, calcium carbonate, and these mixtures will react with the radioactive water. Now, what this is actually called is flocculation. It's kind of a funny sounding word for a cool technology, but what flocculation does is you mix two things together, and let's just be literal here. What's happening is that the radioactive particles and fission products will be encouraged by chemistry and physics to connect themselves and to adhere and stick to, react with iron, react with carbonate. And because this iron is heavy, these iron particles are heavier, these carbonate particles are heavier, what you can do is mix these two things together in tanks. The radioactive particles interact with the iron particles, and then you can spin the tank, or you can let the tank settle. And now these little particles of radioactive stuff you want to bind to floats to the bottom of the tank. And it stays at the bottom of the tank. And then the water above all of that, you move on to the next tank. Okay? So at each step in this process, you're putting in a mixture, reacting it with the radioactive water. Some of the radioactive elements are weighed down by the particles that you're introducing them to. They settle to the bottom. Those can be disposed in a different way. But the water, the runoff, or effluent, as we would say in engineering, goes to the next tank. And you can keep doing this until you have removed a sufficient amount of radioactive material. So when this water gets to the ocean, the vast majority of the nuclear material will be removed from it. That being said, it will still have one radioactive particle in it, and this is tritium. Now, you may have heard of tritium and deuterium if you like Spider-Man, but tritium is a hydrogen atom with 2 neutrons on it. Usually, hydrogen doesn't have any neutrons. It's just a proton. So usually, hydrogen just has a proton. If it has an extra neutron, it's deuterium, and if it has 2 neutrons, so it looks like a Mickey Mouse face, then it's tritium. Tritium is very rare naturally. It occurs when cosmic rays from space hit the nitrogen in our atmosphere. It can create tritium. So there is a little bit of tritium on Earth, and it is radioactive. So tritium will be present in the water from Fukushima. Why is this not a problem, you say, Kyle? Well, the tritium concentrations here that we're talking about are going to be so low that they will be below even international standards. And the amount of tritium that will be released is lower than the background dose of radiation in the oceans, even in the atmosphere. As OG Matterbeam pointed out in the chat, you would get more of a radioactive dose from taking a flight to Japan than you would interacting with this water. So this water is diluted to such a point that the tritium concentration will not really be an issue. And even if it was an issue, it's not as bad as you think it is. Not all radioactive elements are created equally. Tritium, for example, has a very short half-life of just a couple of days, which means that it's very unlikely to what we would call bioaccumulate in the ecosystem. So something like mercury, you hear about this like mercury in tuna, for example, and that's dangerous because mercury doesn't really go away. It just hangs out. And so as it travels, through the food chain, it can get, as one animal eats a lot of animals and that animal gets eaten and that animal gets eaten, the concentration of mercury will accumulate. But when you have an element like tritium that is decaying over time quite rapidly in comparison to something like uranium, then you will not have this same dangerous bioaccumulation, and it's a very weak radiation source. If you held some tritium outside of your skin, it wouldn't even penetrate your skin. In fact, we use tritium to and some phosphorus compounds to make glow-in-the-dark watches and stuff after we discovered that if you do that with radium, it gives you really bad cancer. So, putting all this together, we have a plan that will take decades, mind you, of a very diluted release of very weakly radioactive material into an ecosystem where the background rate of radiation is already higher. So should we really be afraid of this plan? Should there be such fear-mongering just because it is, yes, radioactive? I do not think so. The plan does not call for that. And if we do it right and we follow the engineering principles of water treatment and release back into the environment, it should not be an issue. So if you see anyone having an issue with it, well, then I'm going to take issue with them. But what do you have to say? We have Dorian Adams with the 20 says, Kyle, I love you. Also love physics and want to do something in my life with it. I love black holes, neutron stars, dark matter, and energy, etc. Not as interested in the math itself or planetary science, if that makes sense. What would you do? I would go to school. The only way to really do physics or astronomy or astrophysics in earnest and learn something about the universe is to be associated with an institution that has the materials and the resources for you to do so, and also the knowledge and the other people who can help you out. I do have some bad news for you, is that if you want to go into physics and do it as a part of your life and you don't like the math, that's going to be a problem. So you might want to find a way to make the math work for you, or at least get more excited about it. John McGuire with the 5 says, hey, love, show the Kyle. Finally catches me in office hours live. Stay hype and simp for science. Oh, I'm hyped. I'm so hyped. It's true. Alto Eager with the 10 says, hey Kyle, heart the show. I got lost in sublevel 12 a couple days ago and noticed one of the Kevins was scraping microbial plaques from some of the condenser units. Be careful with what he hands you. No, it's fine. Any Kevin who comes into my office first has to go through one of these, let's just call it what it is, a laser bath. And so nothing really makes it to me. I don't like touching people. Cheech Ola with the Australian $31, as usual, says, g'day Kyle. How do some animals know where to migrate for mating, feeding, and birthing? How does that instinct work? Or is it genetic memory? Cheers, you legend. That's something that's still being investigated. Just how some animals can make these expansive, these many week or month or thousands of miles trip to where they were born. That's still sometimes a mystery for certain species. I think the idea that is getting the most traction or has been shown is some magnetosense. So something in the metabolism of these creatures, like birds, that gives them a sense. I think it might even be a quantum mechanical thing, but gives them a sense of the Earth's magnetic field. And so when they are born, if they have some sense of the magnetic field, then later on when they're ready to mate, it stands to reason that they might be able to navigate Earth's magnetic fields back to where it felt the same. Something like that. Or sharks are incredibly sensitive to... I don't think this figure is right. Maybe it is, because if it is, it's amazing. But sharks, for example, are incredibly sensitive to temperature, and so that's how they could navigate ocean waters. They're so sensitive, in fact, that the figure the example I heard, and I don't know if it's true, but the example I heard is that they'd be able to feel the difference in an Olympic-sized swimming pool if you threw one ice cube in it. That's it's unfathomable. We can't even imagine something that sensitive. That's not true. Our fingertips are insanely sensitive, but Breadboard with the $50 donation says, Lady Kyle Trescu memes are the tippity top of Simp Mountain, only halfway up. Think about it. Yeah. Oh, we'll be looking at some of your Lady Kyle Trescu art later on. As Capcom told me, if you Vamp Mommy Sims want to know this, they don't pronounce it Lady Dimitrescu, even though it's spelled that way. It's Lady Dimitrescu. Consonant right on the end of it. The Common Folk with the 10 says, hey Kyle, love the show. Just want to say hello from South Wales, UK. Well, hello there. I don't know why I sounded like that. VFF says, hey love, Kyle the show. Are there other universes? I don't know. Maybe. The problems with theories that there are alternate universes or bubble universes or parallel universes, what have you, is that there's no real way to test for that right now. There's no experiment that we could do. There's no data that we could gather that would say, yep, other universe. So right now it's just ideas. Stephen Fenn, the 5, says, hey Kyle, love the show. Just want to say you are awesome. Keep up the good work. Oh yeah? Prove it. Just being aggressive. Hey. Katie Trinity Blade, the $20 donation. Kyle, your video about Asperger's may have changed my life. I've been so closed off for so many years. You live your motto, be kind to each other because that's all we got. Thank you. Well, thank you, Katie. Thank you for being you. And if your middle name and last name is truly Trinity Blade, then you have nothing to worry about being closed off. Because when you open up, people are going to be like, damn, now that's a person with a cool-ass name. Saf with the 5,000 yen, which I think, don't you divide by 10? Woo! With the or 100, right? 50. With the 50, the 5,000 yen from Japan. Hey Kyle, I just realized how very much I want you to do a video about the Radium Girls. Yeah, so I'm working on my next Half-Life Histories right now. It will be about something that I will tell you about later. The problem with the Radium Girls and other topics that many of you have suggested to me, the problem is some of those more well-known incidents are so covered already. Some have actual, Hollywood movies and books and documentary series on them. And so for those topics, there's not a whole lot of room for me to add to it. And I want to pick topics that are either not very well known or topics that I think I could do better than what I've seen. And the topic that I've chosen, I think, is going to be a good one. It actually ties into another one that we did, the Body Snatchers of Los Alamos. So the next one, it's going to be good. I kind of pick those. Sometimes I just read a single sentence about the incident. And sometimes there's a single sentence in there. It's like, yep, I'm doing it. And this one definitely had that. It's, gets a little gruesome, but it's interesting. Boise Freerunner with the 10 says, spent some time with my own man recently. He believes that the climate is changing, but as a part of a natural cycle, and that humans are too insignificant to be the cause. How can I show him the light? I mean, it's hard if you're not willing to acknowledge that humans are one of the most powerful forces on Earth right now. I mean, with 7 or 8 billion humans on Earth, there's not that much on Earth that outweighs us. There's not much on Earth that we can't do. We can see what humans have done from space. We can see our scars on the environment. Is it that crazy to think that an animal that has more or less caused the elimination of half of the animal species on Earth, is it that crazy to think if we can affect the ecosystem in that kind of way, that we can affect the atmosphere too in that kind of way? We are releasing trillions of kilograms of carbon dioxide into the atmosphere. It's simple physics, really. I mean, with these gases, the more you emit, the more there's going to be a feedback loop of warming if the ecosystem can't handle it, if it can't dissolve into the oceans or be inhaled by the trees. And we are at a point where we're emitting more than can be inhaled by the trees and absorbed by the ocean. So it's not really a matter of, is this possible? It's really now a matter of how quickly is this going to happen? I hope that helps, but we can talk more about that later. White Hot Shaft with the 20 says, liquid fluoride salts thorium reactor needs to be a thing to keep these issues from happening and make us all zero carbon. Let's carbon neutral. Let's pause the super chats for a second so we can get on to the next topic. But yeah, thorium reactors are... Excuse me. Thorium reactors are a promising new technology. They're experimental at this point, but they'd be very energy efficient and safe. You can't weaponize them, but they're just on the periphery of feasibility at the moment. But do you know what is feasible? Having billions of T-Rex. Oh, jeez. These are T-Rex. Again, T-Rex is plural, so just say T-Rex. These are T-Rex. And what paleontologists have been thinking about for many years is population size of the most famous dinosaur. How many T-Rex wandered the Earth? Now, obviously, this is very hard to do, to come up with an estimate like this, because I don't know if you're aware, but each fossil that you find is a miracle. Not a miracle because those don't happen. But it's so unlikely in the first place to find a fossil that it's very hard to infer how many animals existed from just a few fossils. If you think about how many animals, it's kind of like a reverse Drake equation, right? If you think about how many animals die, and then what fraction of those animals die in the right conditions, what fractions of those animals die in the right conditions and then aren't completely torn apart by predators or have their bones eaten or ingested or something like that, what fraction of those that don't go through that die in a situation where they can be covered by peat in a peat bog or some kind of landslide or at the bottom of the ocean, what fraction of those creatures will go through a successful fossilization process, what fraction of those creatures will eventually, in millions of years, will be brought up to the surface of planet Earth by geological forces, and what fraction of those will ever be near human areas, and what fraction of those will ever be uncovered by humans. If you go through the fractionality of it, I don't know if that's a word. Finding a fossil is a tiny scientific miracle, so to speak. So again, it's hard to tell how many animals existed just from fossils like these ones. So this is a T-Rex fossil, fossil jaw, and I don't have much to say about this other than that. Have you ever wondered why T-Rex teeth are jagged like this and not in a straight line like yours and mine? It's because, I only learned this a couple years ago, it's because, like a shark, when they bite down, or when they did bite down, if a tooth broke off, there'll be another tooth that would come in to replace it. And so if these are breaking off at different places and times, then they'd be growing at different rates, right? If this one broke off last year, but this one broke off, 6 months ago, and that was 2 years ago, then they'd all be at different lengths in the mouth. And that's why they look like that, which I didn't know. So it's hard to tell from just a fossil. So what have paleontologists done in a new study? They used something called Demuth's law. And what Demuth's law is, it's a way to estimate, as you see behind my beautiful hair, it's a way to estimate the population density. How many individuals are in a square kilometer? You just pick a square of land. How many animals can we expect to be in it? That's a population density. What's a population density of certain animals based on body mass? Now, just because of how, food chains work, the bigger you are, the less of you there are, because you need more food, more energy than the, as we would say, trophic level below you. And so apex predators tend to be in the smallest numbers in any food chain because they need the most energy. And they take longer to gestate, and they live longer. Okay. So using Demuth's law, these paleontologists figured that T-Rex is somewhere on the far right of this graph. They were very heavy, thousands and thousands of kilograms, like 5 tons. So what, 10,000 kilograms. And that means that their density in the population would be pretty small, relatively speaking. Now, I will point out that there are complications with using a chart like this, or Demuth's law, and this is what the paleontologists themselves ran into. If you see on the graph here, there is a jaguar and a spotted hyena, which, if you look at it on the graph, are at the same body mass, but they have very different population densities. That is to say, there's many fewer jaguars in an area than hyenas, even though they're at the same mass. Why? Well, inherent to this graph, what you're not seeing in numbers, is that there needs to be some ecological weighting factor, which is to say, you need to take into account how the animals actually live and how they operate within an ecosystem to determine how many of them there will be. Hyenas live and die in a very different way than jaguars, which are more solitary. Hyenas roam around in packs, that kind of thing. So depending on how this animal fits into its niche, They can have a very different population density. So that is what is difficult about using this and using it for T-Rex, because we've never seen a T-Rex. We don't know how they really operated in their environment. We have ideas. So what did the UC Berkeley scientists do? Well, they first tried to estimate the sexual maturity of T-Rex. So they're trying to see how many generations would exist over time, and then work backwards to some kind of population density. They estimated the sexual maturity of T-Rex was 15.5 years. Maximum lifespan was probably only into its late 20s. Average body mass, 5.2 tons. They also tried to find data on how quickly, based on fossils of juveniles and adults, how quickly T-Rex grew during those 20 years. They found that they had a growth spurt around sexual maturity and could grow to weigh about 7,000 kilograms or 7 tons in the end. From these estimates, they then calculated that a population, a generation within a population, would last about 19 years. So then they found that an average population density would be about one dinosaur for every 100 square kilometers, so each one of these T-Rex had a large space to roam about in, which makes sense if it's the apex predator in that area. So if they have a total, now you have some population density, then you apply that to the total available geographic range of T-Rex. Where did it, based on fossils and where you found them, where were they? How much space did they have available to them? Well, if you have the population density, and then you have the surface area, and you know that the population of T-Rex survived for about 2.5 million years, that calculates at any one time a standing population of T-Rex of about 20,000 on the face of the earth at any one time. Now this sounds about right? Think about any other apex predator in the environment. I'm often shocked to learn just how few lions there are, or how few tigers are left. Well, they're endangered, but it's not like there was 10 million of them at one point. No, there's only a few tens of thousands. And that's, again, because of their ecological niche. So about 20,000 T-Rex at any one time on the Earth. But over that 2.5 million years, which is 127,000 generations, that means about 2.5 billion T-Rex walked on this earth. And I like that figure because I think at least me, I was obsessed with dinosaurs when I was a kid, and you have this idea in your head that there were so few T-Rex. Like, once in a while, you might see one lumbering across the field or what have you in their range, and they seem so rare. And so, if one were to be around, it would be an amazing occurrence, right? But using paleontological data and estimates and some laws that apply to other animals, they estimated that billions walk the earth over those millions of years. Now, the scientists point out that this is a pretty uncertain relationship, the T-Rex and the Demuth's law. Their estimates vary by 2 orders of magnitude, which is 100 times. So they could be, okay, well, we said 20,000, but it could be 2 million or it could be 200. Sorry. So it is a very large variation. So they could be totally wrong. But right now it does kind of fit with what we know about ecological predators. And I'm just trying to find one thing here. Ecological predators, apex predators. I'm trying to find one thing here because, like I said, they were trying to find a niche to put T-Rex in to apply it to this relationship, the Demuth's law. And that really depends on how these animals acted in the environment. How warm-blooded are they? We learn more and more every year about how dinosaurs probably weren't just like cold-blooded lizards. They could be very active, even gigantotherms, so heavy that they generate enough heat to be more or less warm-blooded. And, okay, yeah. As part of the calculations, I'm quoting here, the scientists chose to treat T-Rex as a predator with energy requirements halfway between those of a lion and a Komodo dragon. That kind of works, right? It's kind of like a lion mixed with a Komodo dragon. Mixed with, what are they called? A Deathclaw from Fallout. So I want this to kind of reframe how you think of dinosaurs in your mind. They weren't these one-off monolithic creatures. They had large population sizes and operated in food webs, and there may have been, over the course of our planet spinning, billions of T-Rex. I think that's awesome. But what do you think? I have Tim Thomas with the 20. Ow. He says, Kyle, I just want to say that I totally dropped the nuclear energy episode on my online environmental science class, and my teacher absolutely loved it, so much so that she included it in an email to all the students. Thank you so much. Having an impact on students, teachers, and classrooms is some of the highest praise that I can get. Thank you for doing that. And if it helped you or your teacher or your class at all, that's all I can do. I don't make my videos for classrooms, but I do try to make them as widely available and applicable as possible. So I love that. And thank you for doing that. Chantal Picard Maneuver says, love your show. Newbie 101 says, someone please draw a Komodo dragon wearing a lion suit. I agree. Kara Wolf says, I love tuna. This is why I love reading the chat. Chris Herndon says, I joined for the nuclear stuff you do, and then I stayed for the sexy Rexy boy. Now I'm thinking of Lady Dimitrescu as a T-Rex in a dress, doing some stomping. And we'll get to that. We'll get to that. Spasmodius with the 5 says, hey, Kylie. Don't call me that. Welcome to Costco. I love you. What? What's happening? I have a very important question. Was water wetter when dinosaurs were alive? #, simp for science. Yo, are you okay? You sound like you were taken over by a teenager. Was water wetter back when the dinosaurs were roaming around? Yes. Too Many Goats with a Canadian 2542 says the number of T-Rex will definitely include the number 42 because that's the answer to everything. The big question is, how many will Elon Musk breed back into existence? Hey, if it gets him press, he'll probably do it. Wouldn't it be cool if we like launched a car into space? I know he doesn't sound like that. He sounds like more like yeah, actually with the Starlink rocket there's really no side limit. He's more like that. He sounds more like that. Let's move right along, shall we? To what? What do I want to talk about? Let's talk about some real simps. Oh, man. Oh, man. Okay. We're moving on to peer review. So, as I want to do every week on Office Hours, I take one of your comments, questions, or corrections from the latest episode of the facility, and I highlight it, and I make you an honorary member of the facility, and then Kevin gives you a plaque. He's got a plaque. Kevin gives you a plaque, and then you go tell your friends and you brag about it. Last week at the facility, I published a video about what would happen if Lady Dimitrescu stepped on you. If you're not aware of this meme, it's from the new Resident Evil game. She has a 9'6" vampire mama who the internet, well, I say the internet, but more like just horny dudes, have turned into a meme. And one of the things that this meme requires is that she steps on you, possibly killing you. What I, for science, what I did was I put about 400 pounds of weight on a similar diameter bolt to a high heel shoe, and I found that it could crush a coconut like your skull, like it was nothing, and it could go right through your simulated flesh like it wasn't even there. In response to this episode, and because I asked you to, many of you, many of you drew absolutely phenomenal fan art. So to all of you, if any of you artists are watching, I try to tag you all on Twitter. If any of you artists are watching, you're right, Zerv DA. It's not just horny dudes. It's everybody. Everybody on the internet just being horny on main, as people say. I don't know. I don't talk to people. But y'all did amazing, amazing fan art. I love it. I even changed my avatar on Twitter for the first time in like 2 years. So thank you all for doing that. And because so many of you were so enamored with this episode, I kind of wanted to just highlight a couple of let's look. Just some guy says the internet, Kyle says the internet was a mistake. Yes, the internet was a mistake, but tall vampire mommy was a gift. Tyler Sweet says, well, instead of her stepping on you, you could say, gently press your shoe against my face in a non-lethal manner similar to stepping on my face. Bill Smith says, in a perfect world, these are the kinds of videos that MatPat would still be making. How dare you? You come into my comment section and say, this would be better if your friend MatPat did this. First of all, no, it wouldn't. And second of all, leave him alone. Look, he's a busy man. He runs a multi-million-dollar business, and he's super successful, and he's got a lovely wife and a new kid. Shut up. Assman says, quote, I blame DeviantArt for even really making this a question. So we're all the same, aren't we, Kyle? Lorenzo Lazo says, oh, so Mr. Jeff Capcom himself sponsored this video, and the thing they wanted you to do is calculate what would happen if she steps on you. Glad Mr. Capcom is embracing the meme. What I should say is when Capcom reached out to me to do a science video, they did mention the tall lady meme, and I pitched them a full lean into the meme. I said, look, they loved this. I'll make something. I'll make a stepping mama machine. And they came back to me and they're like, why don't we do something else? And then I went back and I was like, you know what? I really think you should do the meme. And a few days later, Kotaku publishes an article about my video and they start trending. Should say, though, that if you've seen the Kotaku article, don't click on it. It is there's like 10 sentences, and in between each sentence is a full page ad. And they only embed my video at the bottom. Anyway, I wanted to highlight all of you who left lovely comments about all this ridiculousness that we got up to. So I'm going to pick one of you right now. Bill Smith, who said the comment about MatPat, these are the videos that MatPat should be doing. Bill Smith, you are now on probation at the facility for the next 3.5 millennia. Amazing. Amazing. Kevin, get the restraints. What's that? Oh, yeah, I mean, they could look at one more horny on main if they want to. Sure. Okay, I'll be right back. Mike McLaren says, Lady Kyle Tresk is my city. I've never heard that expression before, but now I'm going to use it. That thing is like my city. Actually, I hate it. I'm never going to say it. Dark Matter Beam. Ooh, hey, Matter Beam, look, you have a count. Someone made an arch villain for you, which is, I think, your profile picture, but inverted. Ooh, the plot. She thickens. Dark Matter Being with the 5 says, the difference between how we perceive time and how time actually is, akin to how humans recall memories versus how hosts recall memories. Quote, is this now? I don't know if that was just me, but that was very hard to read. The difference between is what you are experiencing now actually now. It's hard to define what now is. It's hard to define what time is. But what I would say is that what you are consciously perceiving right now, no, is not now. Because you know that there has to be a time delay between your sensory input, hearing a sound, seeing something, a photon hitting the back of your eye. You know there must be some time delay between a photon hitting the back of your eye and being interpreted by your brain. You know that can't happen instantaneously. There are nerves. They can only transmit signals so fast. And because of that, you are living life on a delay. Well, how can you get through life if you're on a delay? If you're not actually experiencing things in real time? What if you just step out on the street? Wouldn't you always get hit by a car? Well, that's the trippy thing, is that your brain, you as an organism, are reacting to, making decisions, simulating environments, and operating as though you're not fully conscious. There's a lot of things that you do that are subconscious. And if you go even further, it's increasingly, in my view, scientifically accurate to say that all of your actions, feelings, intentions, thoughts arise randomly, instantaneously, from nowhere in your brain, only to be reacted to a few milliseconds later by your conscious self, which would mean free will is an illusion. It would kind of have to be if you don't live now, wouldn't it? No, okay, don't think about it too hard. Cringe with the 10 says, is there anything interesting about how big creatures like dinosaurs could breathe? Something tells me that breathing would be difficult at that size. I actually don't know what the system was like for dinosaurs. I don't know if they had a... So we breathe in a tidal fashion. Tides go in, tides go out. Can't explain that. Yes, we can. You're dumb. Bill O'Reilly. So we breathe in a tidal fashion. When you breathe in, all of you, big breath. Come on, big breath. In and out. The air coming in still mixes with air going out, and you have this constant ebb and flow of the same volume of air in your lungs. Birds, for example, don't do this. When they breathe in, there's valves, let's just say, valves that shut off such that air is only going one way through different chambers. And so there's no tidal mixing of in and out air. I don't know if dinosaur respiration is closer to birds or closer to mammals. I don't know. If someone wants to put that in the chat, they could say. But I would guess it's not. It's closer to birds than it is to mammals because of evolution. Jeremy Hamrick with the 19 says, Kyle show, hey the love. How does 2D exist even if even the smallest known particles have length and width and height? How does 2D exist? Does it? We can imagine 2 dimensions, and we can picture 2 dimensions mathematically, but to say that 2 dimensions exist in space-time, you have to ignore 2 other dimensions, right? So maybe I'm not understanding your question, but 2 dimensions are a component of the reality of space-time, which is 3 spatial dimensions and 1 temporal dimension, time dimension. So maybe I'm not understanding, but 2 dimensions exist because 3 dimensions exist. I don't know if that's getting around your question. I'm sorry if it is. Pharrell Beast with a 25 says, wanted to thank you for the antimatter you sent me. Kevin1137, Kevin1337 said, don't pay you through here, though. Keep up the great work. Your product is top notch. Oh. Yeah. Yeah, no, you know who it, you have caller ID. Yeah, Feral Beast. Yeah, no, we have his PayPal information. He gave me $25. Yeah, real dumb. Yeah, anyway, so I sent him a gram of antimatter, and a gram of antimatter, no one told me this, costs about $63.5 trillion. So if you could go ahead and just repo that, that'd be, what? Oh. Well, if he sat on it, if he sat on the capsule and he annihilated his butt, then problem solved. Only $63 trillion down the drain. What am I? Student loans? You can stop laughing. It's kind of sad. Bye. Love you. Where was I? What am I doing? Atharva Mandrekar with the 745.48. Don't know what the money symbol is. Could this process of cleaning radioactive water be used once we nuke the polar ice caps to melt the water? There's probably an easier way than nuclearing the ice caps. It's a lot safer. But yes, any contaminated water will go through a similar process where we use some mixture to react with the water to pull the radionuclides out of the water. This is we do the same. Why you shouldn't worry about Fukushima's water is that we do the same thing for other very dangerous things in the water, whether it be lead or other contaminants. We can react chemically with those contaminants, and we can make them heavy in like little bits of sand, and they can just float to the bottom, and we just sweep them away, and the water's good. We know how to do that kind of thing. Tobin with a 15 says something I think is a fun question. Instead of creating a raw AI, would it be easier to instead map a person's neurological activity maybe over years and apply that as code to create sentient machines? I don't know. Well, this is a question of, this is also a question of consciousness. Could you make a sentient machine? Well, this is an open question, so I'm not going to give you an answer. But could you? What is the way to create a conscious machine? Do you have to give it a consciousness like humans from the start, like an operating system or something? Or if you perfectly modeled the brain in a silicon substrate, you made the brain, but just in silica, would it spring to life automatically as conscious? As a sentient being? We don't know. Is consciousness merely a product of the connections in our brain and how they work together? Does this many connections in this amount of meat just breathe consciousness as kind of an emergent property? A symphony of consciousness out of the instruments of neurons? We don't know. We don't know. I certainly don't know. I don't know nothing. Grim Reaper of Trolls with the 9. Do you think we could use the comments saying variations on, "Hey Kyle, love the show," as data points for a psychological study about reading with you as a test subject? No, you don't want to do that with me. I'm extremely good at reading comprehension. I can prove that because I have my SAT scores around here somewhere. I actually do. My mom sent them to me. It was nice. Angie with the 10 says, "Hey from Colorado." Hey Angie, I have some people close to me that live in Colorado. Great place. Would you take kids to Rocky Flats National Park? Is it safe? Do you have any upcoming videos about that? I do not know what you're referring to. Is Rocky Flats National Park dangerous right now? National parks are lovely, so you should go to a national park and support them. But if something dangerous is happening there, I don't know. I don't know. Is it erupting? I don't know. Who am I? A volcanologist? Dashin Moffat says 420 for science, bro. Don't give that. Says I have a fan. It's blowing my luscious locks in my face. Dashin says keep being the ASD science god that I need. That black hole topic before you... Oh, I need that black hole topic before you leave. Can we make it? Can we make it past a black hole with a warp drive? The thing... black holes aren't just inherently super duper dangerous. They're like a point source of gravity like anything else. Now, a black hole with an accretion disk around it might be radiating out dangerous radiation like a sun or a star would. But if you just had a naked black hole somewhere in the solar system, if you don't get close to it, it's not going to do anything to you. You can think about... Here's an example. So think about being at one end of an Olympic-sized swimming pool, and at the other end, someone suddenly opens the drain. Would you immediately feel that? No, right? Only if you got really, really close to the source would you feel a pressure differential. It's not a perfect analogy, but similarly, because the force of gravity is dependent on the inverse square of distance, the further away you get, the force of gravity decreases very, very, very rapidly. So unless you're right near a black hole, it's not going to suck you in like this dangerous sci-fi concept. You can still, if you replaced our sun with a black hole, all of the planets would continue in their orbit exactly. And then 8 minutes later, the sun would go out, and then a few days later, everything on Earth would die. Charlie Spur says 2D does exist, just as a component of 3 spatial dimensions. That's what I said, Charlie! Dang! Leyland Saunders says, hey Kyle, you're awesome. Drew Burgess with a 10 says, hey Kyle, if light is a wave, could you use it as a deconstructive wave for anti-light? Ooh. So if light acts as a wave, could you have light-canceling glasses like you have noise-canceling headphones? So what noise-canceling headphones do is send out a destructive wave that cancels out the wave of what's coming in, like a crying baby too close to you on an airplane. Could you have destructive light? I feel like this is a thing where we definitely have it and we use it, but I can't think of what it is. Could you have a destructively interacting light wave so that you'd have anti-light? I have no idea. I'm gonna... Because light is both a particle and a wave, and something like a pressure wave, that is sound, is not a particle. It just operates like a wave. I don't know if you can have the same thing. I don't think so. Because you'd still have 2 particles of light interacting, right? Well, I mean, when light moves through a medium, light is... it interacts with that medium. It can appear to slow down, but what's actually happening is when light moves through a medium and it appears to slow down, it's the waves of the particles inside that material are destructively interacting with the light, producing a third wave that is moving at a different speed than both of them. And then so I suppose that a material... Yeah, you can have a Bose-Einstein condensate that can stop a wave of light in its tracks. We know this. You can watch my episode about moving faster than the speed of light. You can have a Bose-Einstein condensate, which operates quantum mechanically like one large particle. And one large particle, one large atom would be like one large wave. And if you interact this very super chilled, just fractions of a degree above absolute zero, if you interact that with the right wavelength of light, the light will stop. And that sounds like anti-light to me. As always, as we're winding down, Music Central Piano 29 with the 50/50 dollar donation. Keep up the great work, Kyle. It's a very interesting video last week. Just admit it. You loved it. Came in late to the stream, but remember to restock on copies of yourself. Stay safe and rational. That reminds me, I should hop off right now so that I can get the clone copies of me a-gurgling. A percolating. It's like a French press, but with DNA. Thank you so much for joining me for this episode of Office Hours. What did we talk about? Whew! We talked about Fukushima and why the treated water, if handled correctly, is not going to be the headline-grabbing Godzilla maker that you think it might be. We also talked about how we use estimates and models, though they have many caveats and exemptions, that predict that there could have been billions of T-Rex, Tyrannosaurus Rex on Earth over the course of their time frame. We didn't talk about the first flight on Mars, but hey, a helicopter flew on Mars and it was cool. And we talked about all you simps and what it would take to crush your face with a high heel, and didn't talk to you about what black holes look like when they interact, but here it is. This week on the facility, there will be no new episode, as there usually is on Thursday, because I published one yesterday. It is how warp drives work and will we ever have warp drives, where I interviewed Miguel Alcubierre himself. Yes, the single scientist who popularized what warp drives are. I talked to him for a good 15 minutes, so if you want to check that out, go back to the channel, check that out. That was the most recently published video. And if you want to see the full uncut video where he gets very giddy about warp drives and Star Trek, you can go to patreon.com/Kyle Hill and you can see the full interview uncut there. And also, if you join us here at the facility through Patreon, you can join me on Discord, where I talk and lurk every single day. Over 1,000 of you know that. You know that I'm in there posting the memes and the GIFs. You can get episodes early, you get behind-the-scenes photos, and you get private members-only live streams with me. Not like that, but the professors-only live streams coming up this weekend, and maybe we'll be doing a test case, playing some video games again as we ramp up to streaming the new Mass Effect with Jennifer Hale. Thank you so much for joining me this week. I hope that you have a wonderful rest of your week. Go outside if it's nice outside, get a breath of fresh air, make sure you're eating and getting a lot of fluids, especially if you're getting your second dose or first dose of the vaccine, which all U.S. adults are now eligible for. Stay safe, stay healthy, and be nice to each other. Ow. Be nice to each other, because this is all we got.